So we invest a lot in a technology called homomorphic encryption, which allows one to run an encrypted query against an encrypted database, get an encrypted answer and response, which you can then decrypt. I'll break this down in a way that sort of gives examples of how it can be useful. So let's say that I'm the Centers for Disease Control. I want to know how many cases of flu there are in a particular season. I want to know in a particular city how many cases there are. You have, say, an electronic health record. You don't necessarily want me to see your electronic health record. I don't need to see your electronic health record. I just want to know, is there a 1 or a 0 in your row on having flu or not having the flu? So in principle, the Centers for Disease Control could structure an encrypted query against an encrypted database that holds your electronic health records and a bunch of others that are all encrypted. I can't read those health records, but I can run this query against your data even while it remains encrypted and just know what's the sum of that particular column that lists has the flu. That would be incredibly valuable because we as a society could actually protect data even as it's being computed upon. And thanks to work at IBM several years ago, we know that this is provably possible to run those kinds of encrypted queries against encrypted databases. It's just very slow. So it started out that it was about 1 trillion times slower to do an encrypted query.
So very
Not very
slow.
practical. By the time the CDC found out how many flu cases there are, the flu season would be well over.
The sun burned out or something.
That's right. So we have to bring that overhead down. It's been brought down by 6 orders of magnitude, so now it's only 1 million times slower. We think in this new program that we have called Hector, which is going after this problem, that we can probably bring it down 3 to 4 more orders of magnitude. And then it really would become a practical approach. There's also something called partially homomorphic encryption, which allows you to structure queries in this way that allow you to balance privacy and security in specific cases. There's things like code obfuscation, zero-knowledge proofs, and something else we're doing, which is called classified as a service. We just put out a request for information on how can we use commercial cloud computing in ways that we're sort of protecting the compute as you go, so that if you do get into a machine, you can't run amok. So we're very interested in finding these technology solutions that would allow us to have sort of a non-zero sum approach to security and privacy.